Example 2. Solve each system by elimination. Check your solution. Now, same idea. X's are lined up, Y's are lined up, equals are lined up, constants are lined up. So now we're looking for an opposite coefficient. Well, this one has a coefficient of 1, this one 3. Those aren't opposites. This one has a -3, this one has a 1. Those aren't opposites. So in this example, we have to multiply by a constant first, which means a number, and we're going to pick that number so that we get an opposite coefficient. Now, it doesn't matter which variable we go for. You can go for x, you can go for y. Doesn't matter, but we have to figure this out. So the first thing I'm looking at is I'm going, okay, this is positive, this is positive. Well, that's not opposites. This is negative, this is positive, so maybe I want to work with my y's here. If this is a -3, what can I multiply this by to get it to a +3? And the answer is 3. If I take 3 times y, I'll get 3y, which is the opposite of -3y. But if you're going to multiply this by 3, you have to multiply the entire equation. So I'm going to multiply this guy by a 3. I'm going to leave this guy alone. So we're going to draw an arrow. And I'm just going to recopy x minus 3y equals 24. Then this guy, we're going to multiply everyone times 3. So 3 times 3x, draw an arrow, is 9x. 3 times y is a +3y. Keep your equals. And 3 times 12 is 36. Now I'm going to look at this one more time. And you notice now I have a -3y and I have a +3y. That's what we were trying to do. We finally got the opposite. So we can add. 9x plus x is 10x. -3y plus 3y makes 0y, so it's not there, equals 24 plus 36 is 3, 4, 5, I think 60. And then we solve. So we're going to divide both sides by 10. X equals 6. Then, just like before, we have to take that and substitute it back in. It doesn't matter. You have this equation, this equation, this equation, this equation. It doesn't matter which one you substitute it back into. I usually go back to one of my originals, and I'm going to substitute it right there. So that's going to give me 6 minus, that was the x, minus 3y equals 24. And then I'm going to subtract 6. So -3y equals 18. And then divide by -3. So y equals -6. Final answer, x first, y second, 6, -6. Letter B, x plus 4y equals 22, 4x plus y equals 13. So x's are lined up, y's are lined up, constants are lined up. Beautiful. 1 and 4 are not opposites. 4 and 1 are not opposites. So somewhere I need to make one of these opposites. Now, these are both positive. These are both positive. So somewhere along the line, I need to make something negative. Doesn't matter if we do x or y, I'm going to choose x this time. If this is a 4x, I need this to be a -4x. So the way I make it a -4x is I'm going to multiply by -4. Make sure you distribute to the whole thing. So -4 times x is -4x. -4 times 4y is -16y. And then -4 times 22 is -88. The bottom one, I'm just going to leave alone. So that's going to leave me with 4x plus y equals 13. Now I'm going to take a look at that. I have a -4x, I have a +4x. Those are opposites, so we're ready to add. Negative 4x plus 4x cancel and make 0. Negative 16y plus y is negative 15y. And negative 88 plus 13, I have to grab my calculator. So negative 88 plus 13 is negative 75. And then we solve. So divide by negative 15. So y equals positive 5. Then we have to substitute that back in. Again, it doesn't matter where you put it. I'm going to choose this one. So we're going to have 4x plus y, which we said was 5, equals 13. I'm going to subtract 5, which is going to get me 4x equals 13, 12, 11, 10, 9, 8. Divide by 4. X equals 2. And then final answer, 2, 5. Letter C, 11x minus 20y equals 28, and then 3x plus 4y equals 36. X's are lined up, y's are lined up, numbers are lined up. That's good news. 11 and 3, not opposites. Negative 20 and 4, not opposites. So, if I have an 11 and a 3, can I multiply an 11 to get to 3, or can I multiply a 3 to get to 11? And that one's tricky. I don't think that can happen. But what about a 4 and 20? Can you multiply one of those to get to the other? And yeah, I think if I multiply 4 by 5, I'll get to 20. And then even more importantly, this guy's already positive, so we're going to leave him positive because this guy's negative, and then they would be opposites. So I'm going to multiply the bottom equation by 5. Leave the top equation the same, so 11x minus 20y equals 28. Bottom equation, 5 times 3x is 15x. 5 times 4y is 20y. And 5 times 36, I'm going to grab my calculator. 5 times 36 is 180. And then I'm going to check it out. I've got a negative 20. I've got a positive 20. Those are opposites, and that's what we want. So we're going to add. 11x plus 15x is 26x. These two are going to cancel. Equals 180 plus 28 is 208. Then we're going to divide both sides by 26. Divided by 26 is 8. So x equals 8. Then we're going to go back and substitute that in. Again, it doesn't matter where. I'm going to substitute it back into this equation on the bottom, just because I really don't want to multiply by 11. I'd rather multiply by 3. And you don't need the 5, because that's the equation over here. So 3 times 8 plus 4y equals 36. 3 times 8 is 24. Plus 4y equals 36. Subtract 24. So 4y equals 12. And then divide by 4. So y equals 3. Final answer, 8, 3. Just to sum up a little bit, so far this is what we've done. So methods for solving systems of linear equations. Number 1, graphing. You can graph the lines, you can graph them in slope-intercept form, in standard form by finding the intercepts, etc. And that kind of gives you an estimate of the solutions. When you use this one, always check your answer. I get a little lazy, as you notice in this video. I wasn't really checking, but if you're using graphing, check your answer because your line might not be as exact as you think it is. Substitution, you want to use this when one of the variables in one of the equations has a coefficient of 1 or -1. Substitution is usually pretty easy then. And then elimination. We can use elimination when at least one pair of like terms has the same or opposite coefficients. So this is like the first set of examples we did where we didn't have to multiply by anything. But then there's elimination where you have to multiply first when the variables aren't opposites to start with. So just keep that chart in mind. That's how we can solve a system of linear equations.